Right. Let's continue. Right. So previously, on the previous lesson, we actually sketched the graph and whatnot. So now we are before we can go to the solution of number 2, 3, 4, and 5, I want us to actually see something here. Right. So there is something I want to show you, something powerful, something that is going to help you, right? So let's look at the midpoint. Okay, by the way, what are the coordinates of the point of inflection? Let's have them somewhere here. No, point of inflection, POI, 5/3 minus 286/37. Now let's look at the midpoint of the turning points, right? So that is x1 plus x2, y1 plus y2/2. Right. So let's do that. So x1 is actually minus 2/3, and then plus 4/2. Right. Can you see that? Right. So then y1, what is y1? Is 400/27 plus negative 36/2. Now, if you take your calculator and calculate this, you'll get 5/3. Then you calculate that, you'll get negative 286/27, which is actually the same as the point of inflection. So, what conclusion can you draw here? The conclusion which you can draw here is that the midpoint of the turning points is actually the point of inflection. So, I can say POI is actually the midpoint of the turning point, of the turning point. So the midpoint of the turning point is actually the point of inflection, POI, point of inflection, right? So this is what I wanted to show you. So now, number 2 and number 3 are talking about let's say solution 2, are talking about the increasing and decreasing of a function, right? So solution number 2, right. So question 2 says, for which values of x is the graph increasing? So you see, when you talk of increasing and decreasing, we are actually talking about the first derivative. You're talking about the first derivative, right? For a graph to increase, I mean to say, its first derivative will be greater than 0. For a graph to decrease, its first derivative will be less than 0. Now, let's do that, right? So, remember, for an increasing function, all right, here, for an increasing function, the first derivative is actually greater than 0, right? And now, what is our first derivative? It's actually 3x squared. So we're going to say f prime at x is greater than 0, which is actually 3x squared minus 10x minus 8 is greater than 0. And then when you factorize, you have 3x, then you have x, then you have plus 2 minus 4, and then what are the critical values? It's minus 3 and 4. And then now that means the graph is increasing when x is less than minus 3/2, or when x is greater than 4. Is that true? Let's find out. Right, let's go to our graph. Oh yes, that's good. That's true. Because look at this. When x is actually less than negative 2/3, the graph is increasing. Can you see here? So here the graph is increasing. The derivative here is positive, positive, positive. Can you see that? Even here, it's also positive, 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 positive. Right. So that means we are correct. Yes, indeed. The graph is actually increasing when x is less than minus 2 over 3 or greater than 4. Right, so that is the mathematics. In fact, you can even do this from the graph without even having done the mathematics here. Right, you can actually read this from the graph as I've seen, as I have indicated with the green marker that you can see. Right, you don't have to actually use the mathematics or do the algebra. You can actually indicate that you can actually read the graph and just write the solutions, right? But if you are not sure, you can just use the algebra that I've just demonstrated down there. Right. So solution 2. Solution 3, I'm going to say. So solution 3, we're going to say, so number 3 says for which values of x is the graph concave, is the graph decreasing. So for a decreasing function, the first derivative is less than 0. So the first derivative is less than 0. 3x squared minus 10x minus 8 is less than 0. And then it means 3x plus 2 x minus 4 is less than 0. What are the critical values? Minus 3 over 2 and 4. Right. So that means x is actually between negative 2 over 3 and 4. This is absolutely true because let's go back to our function, our graph. That is true because here now, the slope of the tangent is going down. It's negative. Can you see? Voila. Right? So between these guys, right? So look at this region. Right? So between the turning points, the graph is decreasing. It's going down. It's decreasing. The gradient of the tangent there is 0. Sorry, it's less than 0. It's negative. Can you see that? So also even for solution B, for solution 3, you can read the solutions from the graph if you find it easy or if you are lazy to do the algebra, right? So this is beautiful, absolutely. So now, okay, this one is easy. I'm not going to do the algebra. Number 4, for which values of x is the graph stationary? That is easy. That is easy. Remember, for stationary points, or for the graph to be stationary, the first derivative should be 0. So solution 3, is it solution 3 or solution 4? I think solution 4. Yeah, solution 4, actually, there is when x is minus 2 over 3 or when x is 4. Yeah, when x is here, the graph is actually stationary. It's not moving. Nothing is happening to it. Right, it's not moving. Right. So now let's look at okay, let's look at solution where are we? Solution 5 and 6, right? So it talks about the concavity of the graph. So I will always go back to the graph when actually explaining these things, right? So I think we can remove, but no, it's fine. Let's just leave the green part. I can actually remove this one. Correct. Yep. Right. So let's look at solution 5. So solution 5. So please, on this one, hear me out. Solution 5, they're saying for which values of x is the graph concave up. So for concave up, the second derivative is greater than 0. Right. So for concave up, the second derivative is greater than 0. So the second derivative is greater than 0. 6x is greater than 0, meaning 6x is greater than 10, meaning x is greater than 10 over 6, which is 5 over 3. That is true. That is true. Now, let's go back to our graph, right? Let's use the blue color this time around. So remember we said this is our point of inflection, right? Sharp. Now you can see now here, from 5 over 3 going to the positive infinity, the graph is actually facing up. right? So it's concave up. As you can see there, it's concave up. It's facing up. It's concave up, right? So from 5 over 3, just after 5 over 3 to the right, or to positive infinity, the graph is concave up. You can also read this from the graph. In case you're given the point of inflection on the graph, you can do that. Right, so now let's look at the last solution. And I guess you can already see what solution 6 has in store for us, right? Now, for concave down, the second derivative is less than 0, right? So for concave down, the second derivative sorry. For concave down, the second derivative is 0. So there we have it. So 6x minus 10 is less than 0. 6x is less than 10. And then x is less than 10 over 6. And x is less than 5. X is less than 5 over 3. Yes. So 5 over 3, unless the graph is concave down, as you can see here. Let's use a highlighter this time around. Let's go for the yellow one. Now, as you can see now here, sorry. Yes, as you can, no, yellow one won't work. Which one will work? Heck no. Okay, let's just stick to the green one sharp. So you can see now here, the graph is actually facing down, right? It's actually facing down. It's actually facing down. Can you see that? So these are the questions that you will come across in the exam. Make sure that you actually understand this. This is absolutely, absolutely important. So I've covered a lot regarding the cubic function. Not necessarily a lot, but I've covered quite a handful. Right. So on the next lesson, we're going to look at something proper, not something advanced, I would say.